want to show you is the tools that I've built. This one's out of old bicycle tires, as you can tell. And kind of their functionality and what their intentions were to kind of make some information that we can map. Now, with this particular one, I didn't actually get to test it because I was young and naive and didn't quite understand the geometry that would be involved. And I welded it in the bed of my truck, but I just didn't take into account that when I moved the truck, I mean, the angles are going to change and stuff like that. So I needed to build a base for it that I can rotate mechanically with like a wrench or something. I never built a protractor on it or a compass or anything like that. Anyway, so just give you an idea of how this machine is to work. So this will represent, right, a 180-degree arc of the Earth. Now this, I don't know if you can see it in the screen or not, but that's kind of how it goes. So that would be the same. This datum line here would represent the axis of the Earth, as you can kind of see. If you can zoom in on your screen, I don't know. Now, where this right here is located geographically, it's 37 degrees north. So I have to go 10, 20, 30, 5, 6, 7. So right about there on this compass, or sorry, this protractor, 37, you're about 37 degrees here, right? Roughly. Now, this point of this physical thing will move. See, it goes around. But also, it's on that angle. So if I were to come here, and I were to point the camera at the horizon across this arc, and look at an object on the other side of that horizon, because this angle is getting higher, and then it's getting lower, see, to the ground, the object in the distance is going to change visibly up and down. And they claim that this is what causes the sun to rise up in the horizon and then rise back down. Now, if that's the case, when this goes to the other side of the sun, it's now going to be like this angle. It's going to be the opposite. But you see, the 37 degrees doesn't change. But what happens now it's up here and down there. So if I look across that same horizon, that object should come up to down to back up, because the angle has physically changed. Now, I will draw you a drawing on how this is geometrically established. And you get into, like, I'll even find you an old book where they talked about this, and the sun will actually make a pentagram in the sky. But this is something you actually make an observation with. It's kind of cool now. It's like a little lawn ornament, but I built this one, and I'm going to show you the other ones and kind of go over how they go, and then I'll make calculations, and I'll make the calculations. I won't give you my findings, and I'll just show you how geometry would show a particular outcome. This is just one of the three that I'm going to show you. All right. Can you see me? Okay. Now, what I want to do here, figure out the camera first. Okay, now, inside of these videos that I'm making, we have concepts. So what I want to get out is the concept that the Earth is a ball, and it has two places in existence around the sun. The sun can be anything you want it to be. If I draw it to scale, it's definitely not going to do any justice. Not justice and peace, but justice as like justice or whatever. Okay, here we go. Now, the video this is being tethered to is the idea that the sunrise and the sunset, okay, this would be the dark, this would be the dark. Sun's the giver of light. Okay, now, if my location, okay, this is going to be a poor quality video. The lighting is terrible. As I rotate around the axis, right, what would appear on my horizon is the sun coming into fruition, right? You'd have an arc, and it will set. So we'd have some type of angle, arc angle, to my horizon. Now, if I were to take a point and a point and another point, okay, they would have a vertical height difference. Now, the idea of heliocentrism is that this arc is caused by your location, because it's not the equator. You're like I showed you in that metal wheel, it's physically changing its orientation to the object in the distance. Because of that, as this part goes down around the curve, the sun goes up to the horizon. And that's what causes the sun to go up in an arc. And that would be true. I'm not saying that's not the case. I'm saying that would be true. 100% true. Okay. I agree. Because these things they're non, it's not an opinion. But you see that would be, as I rotate down, I'm rotating around, the angle that I come up at sunrise, see, would be up. Up. I'm rotating up in this angle. Now, on the other side, the other portion, I'm rotating down to the sun. For the sun, in this other spot, I'm going down. I'm going down into the sunrise. And this one, I'm going up into the sunrise. See this arrow? It's the bottom of this board. See this arrow? It's the top of the board. Inside of this orthographic view, they are different orientations. And that was that piece, that metal wheel. And what I found is I couldn't quite get the test I wanted, because I understand that my geographic location and the gravity and the horizontal things, they changed. I never really made the device. I never finished it, so I could never make the tests and observations. But if I'm rotating, it's not a G. Okay, it's not a G. It's a rotation. Alpha, Bravo, Charlie, Delta, Echo. Okay, golf. It's not a golf. It's a spin. So when I see the sun, right, I'm seeing it like this. Spinning around. Now I see the sun on my left, and it goes up because I'm going to my left still. So that would cause the sun to come up, the sunrise. But when I flip to the other side, see, now my sunrise is right here. Before, it was over here behind the ball, behind my drawing. It's on the backside right here. See, right here? In the real world, physical world, that's where my sunrise intersects my horizon. See? Because this is orthographic. This is non-perspective. Well, it's perspective of orthography. So when I see this sun is when I go behind this. So then I see this sun. But it comes up and goes back down because of the curvature of the orientation. On the other side, when do I see the sun rise? Is over here. Is on the face of this board. So I would see it like this now. See? Like this. I see the sun, and I would be looking down at the sun, and then back up to sunset. So the orientation of angle has flipped. And that's what that device was. So, I'd like an explanation, or if you have input, as to why this does not happen. Because the real world and the fictional world are two different worlds. Now, that's what I was saying about that wheel, those bicycle wheels that I welded together and I made that spinny thing. And that was number uno. Okay, let me try another one.